So good morning friends, welcome to Water Resources Engineering class. We are dealing with Unit 3 Hydrographs and we have dealt all the various types of hydrographs starting from storm hydrograph, direct runoff hydrograph, then unit hydrograph, then how to derive the unit hydrographs of different durations, then how to derive a unit hydrograph for a complex storm, how to derive basically from a unit hydrograph to a flood hydrograph. To that extent, we have worked all the different methodologies. Now, in this unit, we work out on the last part of the unit, that is what we call it as synthetic unit hydrograph. So, what is it, this synthetic unit hydrograph? Synthetic unit, an artificial unit hydrograph. What it is? If you see the data in India, for example, only limited number of catchments we have the stream flow data. Because for any hydrograph you want to plot it, stream flow data is essential. For a very, very limited number of catchments, we have the stream flow data. That is the first thing. That is a ground reality. Majority of the basins, we do not have the correct stream flow data. That means they are not at all gauged. We don't have any provision to measure the stream flow in majority of the streams. So in such a case, how to go forward? If you want to construct a culvert on such type of thing, if you want to construct a small obstruction like a weir on that, what to do? So that is why for such type of cases, this synthetic unit hydrograph will be useful to you. That's why please see, in India only small number of streams are gauged. Gauged means the data can be measured. There are many drainage basins for which no stream flow records are available. We do not have any stream flow records and unit hydrographs may be required for such basins, because UH is required to for any construction of any hydraulic structure, we require the unit hydrograph. So in such a case, what you will do, in such a case, hydrographs may be synthesized directly. This is our provision. How? We take the other catchments where there are gauged catchments, where the unit hydrographs available, we take from them actually and try to reproduce towards this. So that means, but while selecting what type of parameters you will see, while selecting naturally these both ungauged catchment and gauged catchment, both should be basically hydrologically and meteorologically homogeneous. Then only the data from one can be useful to the other, or from other catchments through the application of an empirical relationship. Right? There are only two ways by which you can find or you can derive a synthetic unit hydrograph. Is only number one is you select a hydrologically and meteorologically similar homogeneous catchment, and that data you can bring it to this ungauged catchment. That is one method. Or the second method is use some empirical equations and try to get the data. This is the second method. So now what is it? First, synthetic unit hydrograph definition is what? A synthetic unit hydrograph is a method actually. It is a method used to estimate the unit hydrograph. It is a method used to estimate what? The unit hydrograph for a catchment. Which type of catchment? Where the observed stream flow data is not there at all. For a catchment having no observed flow data, for a catchment which doesn't possess the stream flow data, for such type of catchments, if you want to derive an unit hydrograph, then synthetic unit hydrograph is the method for such type of thing. Synthetic unit hydrograph is a method to derive the unit hydrograph for an engaged station where there is no stream flow data is available, then how to do it? How to do it means we use the catchment characteristics. We use the catchment character. What are the catchment characteristics? Number one is the area of the catchment. Number two is the length of the mainstream. Number three is the slope. These three anyhow you can measure at any point of time. So if I am given with what is the area of the catchment, what is the length of the stream, and now what is the slope, if you bring these three things, then actually even though stream flow is not measured, even though the data is not available for us, still you can prepare a unit hydrograph, and that unit hydrograph is called as synthetic unit hydrograph. Once again repeat it. A synthetic unit hydrograph is a method of deriving or estimating a unit hydrograph for a catchment without observed stream flow. But how? By using the catchment area characteristics such as area, length of the stream and slope. This is the first thing. Then it is an indirect method actually, because when I say estimate, it is an indirect method developed from empirical equations or dimensionless hydrographs making suitable for ungauged watersheds. So a synthetic unit hydrograph is an indirect method developed from empirical equations or dimensionless hydrographs making for ungauged watersheds. So what is the significance of synthetic unit hydrograph? It is applicable for the ungauged basins, because synthetic unit hydrograph is only for ungauged stations. Otherwise, generally, automatically, the regular unit hydrograph is available. So when the rainfall runoff data is not available, we will go for this synthetic unit hydrograph. Naturally, this synthetic unit hydrograph also based on certain principles. So naturally, it supports the design of hydraulic structure like maybe culverts, maybe spillways, etc. And it also helps us in forecasting the floods basically. And actually it is also basically because we may have some data regarding some of the catchments, but for providing a uniform method for hydrologic design, naturally this synthetic unit hydrograph is useful, and it eliminates the long-term field data, because you don't require field data to be collected for a long time. Directly you can go for it. This is the significance of synthetic unit hydrograph. What is the use means? Design software. Same. Any unit hydrograph, what is the use? Here also the same. So design of storm water drainage systems, flood forecasting, hydrological modeling, regional hydrologic studies, and initial runoff analysis. So these are the 5 uses of this method. How to construct it? This is our thing. Synthetic unit hydrograph, what it is I mentioned. Then how to construct it, how to estimate the parameters. This is what we need to study. How to construct it. These methods of synthesizing hydrographs for ungauged areas. Ungauged, please remember this always, this important word, have been developed by Bernard, that he is the first person, then Clark, then McCarthy, and then Snyder. So these are the different people who have developed actually the synthetic unit hydrographs in the absence of stream flow data actually. And what we will follow in this particular class is Snyder method, which is the, when I take it, it is more simple method, more rational method also. So that we took it for our regular study. So Snyder method, we are using it. The best approach is due to Snyder. That's what the next. What actually Snyder has done, he has analyzed a large number of hydrographs from different drainage basins, ranging areas from 25 square kilometers to 25,000 square kilometers. So small basin he has taken, large basin he has taken. Between this actually he worked on different drainage basins or catchment areas, and then that analysis part, whatever is taken, that is the basis for him for doing anything regarding the synthetic unit hydrograph. That's what I mentioned. Then finally he come with 3 things. three parameters have to be found out. What are the three parameters? Number one is the base width, number two is the peak discharge, number three is the lag time. So first one is base width. How much should be the base width of the hydrograph? That is the unit hydrograph. That is first thing. Then when the peak is, what is the peak actually? So this is the peak. So what is the peak? And when the peak is occurring? When peak, what is the time to the peak? So this is what. So knowing this starting point, ending point, base. So this. So first one is the base, time base. Second one is the peak. Third one is the basin lag or whatever it is. Lag time, basin lag, all together put only thing is time to peak. Now if you join it, if you want to join by a straight line, then you are going to get a triangle. If you want to join by a curve, actually you can curve. This is how it will be. So this is what a synthetic unit hydrograph is. So he found that there are three characteristics which are very, very important in Snyder method. Number one is the base width of the unit hydrograph. Number two is the peak discharge, peak flow. Number three is actually at what time the peak is going to occur. So that is the three. So if you know these three things, the synthetic unit hydrograph can be constructed. So basin area is A. Now let us talk one by one actually. How to estimate base width, then peak discharge, lag time. What is given data? Basin characteristics, catchment area is given. Mainstream length L is given to you. Distance from the outlet to the basin centroid. Suppose if you take it, this is the stream if you are taking it. So somewhere here the outlet is there. So from this outlet to the centroid of this, this is what we call it as LC in kilometers. So if you know the total length of the mainstream length, then we can find out and what is the average slope. So estimate lag time or time to peak. This is the first thing we have taken. How to estimate the lag time or time to peak? Tp is equal to Ct into LLC whole to the power of 0.3, some empirical equation. So what is Tp? Tp is the time to peak in hours. What is Ct? It is a coefficient. What is L? Mainstream length. What is LC? Distance from the outlet to the centroid, basin centroid. This is what is the thing. So next, estimate peak discharge. What is the first one is time to peak. Second one is how much is the peak. Third one is base width. These are the three parameters. So for first thing is Snyder has given a method on how to estimate the time lag or lag time or time to peak. That is Ct into L into LC whole to the power of 0.3, where L is the total length, LC is the up to centroid from the outlet, and whereas Ct is the coefficient. Then we estimate peak discharge. Peak discharge is equal to Cp into A by Tp. What is these values? Cp is nothing but regional peak factor. A is the area of the catchment, and basically the other one is Tp is equal to time to peak. Just now we have found out. So using that you can find out what is the peak discharge. Number 2 is over. Last one is Snyder method for constructing the synthetic unit hydrograph. What is the base width? Base width is nothing but actually it is equal to, base width is equal to 3 times the time to peak actually. Suppose if you take it, this is this and this is this. For example, this peak is this. Suppose peak has occurred 12 hours from 0. Then naturally total one is how much actually? The total from here to here, it will be 3 times 12, that is 36 hours. This is what is the meaning of this particular general equation. So now if I see it, if I join these 3 things, then naturally what is the thing I am going to get? I am going to get a triangle. And it can be a curvilinear also, a triangular or curvilinear. Mark time to peak, peak discharge, and base width. That's it. But whether your answer is right or wrong, how empirical equations you have used? There are three equations you have used. Naturally, first equation you have found out what is time to this time TP. This is the first thing you have found out. Second one is how much this is. Third one is this is how much. These are the three things you have found out. Now whether it is right or wrong, how to find out actually, and the area under this actually, the area under this must correspond to 1 centimeter rainfall excess. So if I take it 0.36 into sigma O into T by sigma O by sigma U into T by A is equal to 1 centimeter. Because it is a unit hydrograph, because synthetic unit hydrograph is a unit hydrograph. So naturally the rainfall excess should be equal to only 1 centimeter. So if you find the area of the unit hydro area under the unit hydrograph or 0.36 into sigma into T by divided by A, that must represent only 1 centimeter. Then your answer is right. If that doesn't represent 1 centimeter of effective rainfall, then naturally somewhere wrong actually. So what is the method you tell me? First is catchment characteristics, estimation of two things, TP and QP actually. Once this is over, then base width actually, generate the shape of it, then apply 1 centimeter rainfall excess, then find out what is the final synthetic unit hydrograph. Suppose if it is not, you are not getting 1 centimeter, then probably the shapes we may have to change a little bit shape change, you may get the correct answers. If I take a problem, area is given to you, L is given, LC is given, CT is given, CP is given, every data is given. First let me take TP is equal to, that means time to peak is equal to CT into L into LC whole to the power of 0.3, same thing I found out. Then QP is equal to how much CP into A by TP, that's what I found. Then last base width is equal to how much, 3 times this TP, so this is what it. So use a triangular hydrograph with a peak of 9.5 hours and base of 28.5 hours. So what is the limitation of this synthetic unit hydrograph? It's only we are depending on empirical equations actually. So those coefficients are very important actually. So naturally the accuracy of this method really is a doubtful thing. Then is it suitable for all basically catchments? No, it is not suitable for highly urbanized catchments or irregular terrains. Then limited for extreme events. So for example, because we are taking from some other data or you are empirically estimating it, there is every chance that you may underestimate the peak flows in some of the cases. Then lack of physical basis. So all this method is only, we are only proposing such type of things. It doesn't have a solid proof, solid response to take this forward. And calibration needs adjustment using the available data from similar watersheds actually. Okay, we have found it. So, but getting that 1 centimeter rainfall excess is one difficulty. And second one is correlate with any other catchment which is already gauged. So, these are all some of the additional books which you need to follow for this particular syllabus. With this, I completed the synthetic unit hydrograph also. Let us meet tomorrow with another lecture here. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.